Hey everyone, and welcome. Today, we're going to tackle something that sounds like it should be the easiest thing in the world, turning a date time into a simple date. But, as we're about to see, especially when you're in the world of Dynamics NAV, there's a sneaky little bit of complexity here that can catch anyone off guard.
So let's set the scene. You're working in nav. You've got a date time value, and all you need is the date part. I mean, it's a super common task, right? You're probably thinking, there's got to be a function for that.
And you're absolutely right. Nav has this handy little function called DT2DATE. The name says it all, date time to date. It looks like the perfect solution, so you pop that in your code, problem solved, and you move on. Or maybe you don't.
Yeah, this is exactly where the trap is sprung, because that simple-looking function can behave in some really weird, unexpected ways. It all depends on a couple of things you might not even be thinking about, and it can lead to some seriously hard-to-find bugs.
So, what's really going on here? Well, the whole issue basically boils down to two hidden variables that have a huge impact on what that function actually spits out. The result you get isn't always the same. It changes depending on the context.
Let's break these down. First up, it really matters where you're calling the function from. Are you running it from inside Nav's own native code, or is it being called from the outside, say through a web service? And second, it all depends on this one little server setting, the service's default time zone. This can be set to either UTC or to the server's local time zone, and believe me, that choice makes a massive difference.
Okay, so to really get our heads around this, we need to look at some hard evidence. The original source for this deep dive actually ran a brilliant little experiment, testing how the function behaves right around midnight, when dates are about to change and things get weird.
Now, the setup here is super important. Our developer is working in a time zone that's 3 hours ahead of UTC. This 3-hour gap is basically the key to unlocking this whole puzzle.
All right, for the first test, we're going to use a date time that's really late in the evening. It's 11:23 p.m. on June 19th. We're less than an hour away from the next day. So let's see what happens when we try to convert this.
Okay, check out these results. The first 3 rows, totally normal. The date stored is June 19th, just like you'd expect. But look at that last row. Whoa. When the function gets called from a web service and the server is using its local time zone, the database stores June 20th. It literally jumped a whole day into the future. How on earth does that happen? Now, to make sure that wasn't just some weird fluke, let's run another test. This time, we'll use a date time from just after midnight. So, 12:23 a.m. on June 19. And wow, this one reveals a whole different side to the problem. Take a look at the first and third rows. When you call the function from native code, the actual date time that gets stored in the database is 9:23 p.m. on June 18th. The system has quietly converted our local time to UTC behind our backs, and in doing so, it pushed the date back into the previous day. So, what in the world is going on? How are we getting dates from the day before and the day after? Well, the answer is in this invisible automatic process that NAV is running under the hood every single time. Here it is, the secret 4-step process. First, you give it your local date time. Simple enough. But then, and this is the kicker, the system silently converts your local time to UTC. Remember our developer was 3 hours ahead? That means 12:23 a.m. on the 19th becomes 9:23 p.m. on the 18th in UTC. After that, the DT2DATE function does its one job. It just lops off the time component, and the final date you're left with is based on that UTC value, not the one you originally put in.
So understanding that hidden conversion is literally everything. It means you just can't blindly trust DT2DATE. You always have to stop and think about the time zones involved and how your code is actually being executed.
The author of the original post that inspired this whole thing summed it up perfectly. It's a really clever way to remember that whenever you're messing with date times, you have to keep an eye on those hidden time zone conversions happening behind the scenes.
And that really leaves us with one final big question to chew on. Now that you've seen how easily this kind of bug can sneak in, it makes you wonder, doesn't it? How many other little time zone traps just like this one might be hiding in your own code, just waiting for the right time of day to cause a problem? It's for sure something worth thinking about. Thanks for tuning in.